over 3 of the homework problems from section 12.4, starting with number 19. And we're going to fill out as much of this chart as we can. When you first start, if we're given standard form, you try to factor it. Well, actually, before we try to factor it, let's get the y-intercept. And you can always find a y-intercept by plugging in 0 for x. And if you're in standard form, the quadratic term and the linear term are both 0 out, and all you're left with is the constant, which in this case is 2. And so 0, 2 is our y-intercept. Then we go ahead and try to factor this. So we're looking for two terms that multiply to 2x squared and add to 6x. And so we look at the factors of 2. 2 and 1, and that's it, or negative 2 and negative 1. And there's no way to create a 6 by adding or subtracting a 2 and a 1. So there's no factored form. So there's no factored form, then you need another way to find things like x-intercepts or the vertex or the axis of symmetry. And so there's a way to go from standard form straight to vertex form, and that's through a method called completing the square. And so that's what I'm going to do here. So what we do first is we focus just on our terms with x. So I'm going to rewrite this with the x squared and the 6x inside parentheses, and then the plus 2, the constant, on the outside. And then I'm going to factor out a. So a is my leading term. In this case, factor out the 1. Well, if you factor out a 1, nothing changes. I'll just put a 1 out front. It's the same thing, right? And then I'm going to take b, which is my number in front of x, and I'm going to find out what b over 2 squared is. So in this case, 6 over 2 squared is 3 squared, which is 9. And I'm going to add and subtract 9 inside of the parentheses. So I'm going to rewrite it like this. 1 times x squared plus 6x plus 9 minus 9 plus 2. Now you may be wondering, like, why did I put plus 9 minus 9? Doesn't that add up to 0? Why do we need to do this? Remember, our goal here is to get it into a particular form. And so it's not to simplify. It's to get it into this form. And so these are steps that you need to take in order to get it into this new form. Okay? So after you do that, you're inside my parentheses. I have 4 terms. I have x squared, I got a 6x, I got a positive 9, and I have a negative 9. Well, you multiply a, just distribute a, which is 1, to the negative 9, the last term there, to get that outside the parentheses. So now we're going to have y equals 1 times x squared plus 6x plus 9 in parentheses, and then a minus 9 plus 2 on the outside. Now what's in the parentheses is a perfect square, so you factor it. So what we did is we created something that we can factor. And if we factor what's in the parentheses, you're thinking, what two numbers multiply to 9x squared and add to 6x? You're going to get 3x and 3x. So we end up with y equals 1 times x well, I'm going to go through the factoring here. X squared plus, well, let me do the factoring on the side, and I'll pull it over. Oh, this might get a little too long and messy. So if I have x squared plus 6x plus 9 It's going to be x squared plus 3x plus 3x plus 9, which is x times x plus 3 plus 3 times x plus 3, which is x plus 3 times x plus 3, which is x plus 3 squared. Okay, so that x plus 6, x plus 9 is the same thing as x plus 3 squared, and then the negative 9 plus 2 is minus 7. And that right there is what we're going to take and write as vertex form. So y is equal to 1 times x plus 3 squared minus 7. So let's backtrack here. We got something that would not factor, and a lot of quadratics do not factor, and so I'm teaching you a new method called completing the square, which is very helpful for solving and very helpful for getting something into vertex form. So, and this will always work. So now that's in vertex form, I see that my vertex is going to be negative 3, because I have a positive 3 with the x, right? So you take the opposite of that, and then a negative 7. Now I want to find my x-intercepts. To find x-intercepts, you plug in 0 for y into an equation and solve. And you can plug it into standard form, but we don't have that method yet. We're going to develop that, but we don't have that yet. You could plug it into factored form, which we have in the past, but in this case there is no factored form. And so if you have vertex form, you can do that. And you always have standard form, you will always have vertex form. It's the factored form that may or may not be there, okay? So I'm going to plug in 0 into vertex form. And solve. To solve here, I'm going to add 7 to both sides. What's really important here is do not multiply the x plus 3 times x plus 3, don't, because then you'll go back to standard form and it'll make it more complicated. I'm going to just move things, just switch places here. And I want to get rid of the square, so I'm going to take the square root of both sides. And I taught you earlier, when you take the square root, don't forget it could be positive or it could be negative, right? Just as a quick refresher, if I had x squared equals 9, well then x could equal positive or negative 3, because if you square the positive 3 you get 9, or if you square the negative 3 you get 9. So in the same way here, I'm going to get x plus 3 could be positive or it could be negative square root of 7. And then I'm going to subtract 3 from both sides. I get x is equal to negative 3 plus or minus square root of 7. And it's important that you know that that's two different numbers. One of them is going to be negative 3 plus the square root of 7, and the other one's going to be negative 3 minus the square root of 7. So my x-intercepts are negative 3 plus the square root of 7, comma 0, and negative 3 minus the square root of 7, comma 0. And the square root of 7 is less than the square root of 9, but it's bigger than the square root of 4. And so we know the square root of 4 is 2. We know the square root of 9 is 3. So the square root of 7 is somewhere between 2 and 3. So it's 2 point something. And we'll keep that in mind when we're graphing. And let's get to graphing. So our axis of symmetry is going to be x equals negative 3. That's the middle. And so I'm going to move the y-axis to the right a little bit so I can make the middle of my graph kind of in the middle of my picture here. So right there's the axis of symmetry. My vertex is at has a minimum at -7. So there's the lowest point right there at -3, -7. We have a y-intercept at 0, 2. And that's 3 to the right of the middle, so I'm going to go 3 to the left of the middle, and it's going to be the same height because we have symmetry. So we have a 0, 2 here, and we have a -6, 2. And then we have our x-intercepts. And so from the center at -3, I'm going to go to the right square root of 7. Remember, square root of 7 is between 2 and 3, so I'm going to go from the middle, from -3, I'm going to go to the right, somewhere between 2 and 3, so that's going to end up between 0 and -1. Not sure exactly where, but you're graphing, it doesn't have to be perfect. And then from the middle, from 3, I'm going to subtract square root of 7, so I'm going to go to the left between 2 and 3, so about right here. And those are my two x-intercepts. And now I've graphed 5 points of the graph. And I'll label my x-intercepts. So the one on the left side is the -3 minus square root of 7, comma 0. And the one over here is going to be -3 plus the square root of 7, comma 0. Label your points on your graphs. Domain is all real numbers. That will change once we start to get to word problems, but when we're talking about general equations, quadratic, it's always going to be all real numbers. The range, we have a minimum value at -7, so all y values bigger than or equal to -7 in the range of this graph. It's decreasing when for all x values less than the middle, and increasing on the right side of the graph, so when x is greater than the middle. And then I'm just going to put in our 5 points here. -6, 2, -3 minus root 7, 0, -3, -7, -3 plus the square root of 7, 0, and 0, 2. And there we have number 19 complete. Alright, let's take a look at number 21. So 21, I'll try to factor. First I'm going to factor out a -2. And we'll put x squared minus 4x minus 7. And if I were to factor further, I'm looking for two terms that multiply to -7x squared and add to -4x. Well, so what two numbers multiply to -7? Well, it has to be a 7 and a 1. And it could be a -1 and 7, which would add up to 6. Or it could be a +1 and -7, which would add up to -6. Either way, we're not going to get -4, and so there is no factored form. Okay, so then there's a need to complete the square. So I'm going to go through the steps for completing the square again. So first, you're gonna put parentheses around the parts that have the x or the x squared, so your quadratic term and your linear term. Then you're going to factor a out of that, the parentheses. So a is -2. Yes, there's an x, but I don't want to factor the x out. I want to leave the x. I'm only factoring a out. I'm following, by the way, I'm following these steps here. Okay, so if you're wondering what I'm doing, I'm following those steps one by one. So factor out a negative 2, and I'm left with x squared minus 4x plus 14. Then I take what's in front of x, so I'm going to call that b, okay, the negative 4, and I find out what b over 2 squared is. So b is negative 4, so negative 4 over 2 squared is negative 2 squared, which is 4. So I add that and I subtract that inside the parentheses. Next step, I take the a, which is negative 2, and I multiply it with the last term, which is the negative 4, to distribute that and get that negative 4 outside of the parentheses. So that's going to look like this. So we get y equals negative 2 times x squared minus 4x plus 4 plus 8 plus 14. So that plus 8 came from me multiplying the negative 2 with the negative 4. So that got out of the parentheses, and I'm still left with 3 things inside. Now the 3 things that are left inside your parentheses will factor. And it should not only just factor, but it should factor to be a perfect square. That's why we call it completing the square. And so let's just verify that. So I'm going to write over here, I got x squared minus 4x plus 4. That's what I have in my parentheses, right? And if I try to factor this, we have two numbers, or two terms that multiply to 4x squared and add to negative 4x. And that's going to be negative 2x and negative 2x. If I continue to factor this, you see I get x minus 2 times x minus 2, and that's the same thing as x minus 2 squared. And so, alright, y equals negative 2 times x minus 2 squared plus, and then 14 and 8 gives 22. And that, I just converted it now to vertex form. So I'm going to write that in vertex form. So y is negative 2 x minus 2 squared plus 22. We call it vertex form because we can easily look at it and know what the vertex is. Inside the parentheses you got x minus 2, so your x value will be positive 2. And then it ends with a plus 22, so you end with a plus 22. And the line of symmetry is the x value, which is 2. To find the zeros, which is the same way you find the x-intercepts or the roots, you plug in 0 for y, and you solve for x. Now when you're solving from vertex form, keep the x minus 2 squared alone and get rid of everything else. So like you're solving for the part that's squared first. And so I'm going to subtract 22 from both sides. And then divide both sides by negative 2 so that I can get that x minus 2 squared alone. Then I'm going to take the square root of both sides. But let me flip both sides around. I'm going to put the x minus 2 on the left hand side and the 11 on the right hand side. And then take the square root of both sides. But don't forget the plus or minus with the square root of 11. And you end up with x minus 2 is positive or negative square root of 11. So x is going to be 2 plus or minus square root of 11. And so our zeros are x equals 2 plus the square root of 11 and x equals 2 minus the square root of 11. And when I use my x, when I find my x-intercepts, they are going to be 2 plus the square root of 11 comma 0 and 2 minus the square root of 11 comma 0. And the square root of 11 is between the square root of 9 and the square root of 16. Square root of 9 is 3, square root of 16 is 4, so square root of 11 is 3 point something. And it's going to be closer to 3 than it will be 4, right? So it'll be 3 point something. Alright, our y-intercept, we haven't gotten that yet. Y-intercept you easily get from standard form because you plug in 0 for x, and the quadratic term, the ax squared, goes to 0, the bx goes to 0, and all you're left with is c. So in this case, c would be 14. So 0, 14 is our y-intercept, and now we're ready to graph. Okay, so the center here is going to be at 2. Y-intercept is 0, 14. And so we're going to have a matching point on the other side at 4, 14 using symmetry. The x-intercept is 2 plus the square root of 11. So from 2, I'm going to go to the right square root of 11. So I'm going to start at 2, which is the center, and go a little more than 3. So 1, 2, 3, so about right there. And then from the center, I'm going to go to the left 3. So 1, 2, a little bit more than 3. It's about right there. So those are my two x-intercepts. And my vertex is at 2, 22. So we see that this parabola is going to open down, which makes sense since a is negative 2, and if a is negative, it's going to open down, and I'm going to label my x-intercepts here. So this is 2 minus root 11, 0, and this is 2 plus root 11, 0. Domain is all real numbers. Domain always talks about how far left or right in your graph. It's dealing with the x-axis or x values. The range, you have a maximum at a height of 22, so all y values less than or equal to 22. It increases on the left side of the graph, so when x is less than the middle, and decreases on the right side of the graph, so when x is bigger than the middle. And the 5 points we use were in 2 minus root 11, 0, 0, 14, 2, 22, 4, 14, and 2 plus root 11, 0. Alright, last one, number 24. Okay, again, we can try to factor this thing. So if I factor out a negative 3, I'm left with an x squared plus 4x plus 1. And so if you try to factor further, you're looking for 2 terms that multiply to x squared and add to 4x. So what two numbers multiply to 1 and add to 4? 1 and 1, add to 2, negative 1, add to negative 2. It's just not going to work. Doesn't factor. Got to use the completing the square. So first step, parentheses around your quadratic term and your linear term, the terms with the x squared and the x. Second step, factor out a from the parentheses. So factor out a negative 3. Third step, find out what negative b over 2a is. So negative b over 2 squared. Negative b would be negative 4. So it's negative 2 squared. Said negative. It's just b over 2 squared. I don't know why I'm saying negative. It doesn't matter. The negative is going to be squared, but it's just b over 2 squared. So you get 4. So you're going to add 4, and then you subtract 4 inside the parentheses there. Then the next step is you take the negative 3, the a, and multiply it with just the last term, because we just want to get rid of that last piece, or not get rid of it, but take it out of the parentheses, because our next goal, our real goal, is to be able to factor, and we want only 3 terms to factor. So I'm going to rewrite this now. Y equals negative 3 times x squared plus 4x plus 4 plus 12 minus 3. And I'm going to bring you back to the last problem we did. Notice on 21, I'm going to highlight it for you. This piece right here is x squared minus 4x plus 4. And that's exactly what we have now. And notice what it became. It became x minus 2 squared. Remember, we did all the work here to find that. And so I'm just going to carry that over to this problem because it's going to be the same exact work. So if you recognize that you've already done it, you don't have to do it again. So this is negative 3. This is going to become x plus 2 squared. And then 12 minus 3 is 9. And so we just found our vertex form. I'm going to write that out here. Negative 3 x plus 2 squared plus 9. Hopefully you're already having an idea now. When you graph this, is it going to open up or down? You should think, oh, it's opening down because a is negative, right? We can see our vertex is going to be at negative 2, comma 9. Line of symmetry is at negative 2. Y-intercept comes from standard form using the constant, which is negative 3. Okay. And now let's find our roots. So I'm going to subtract 9 from both sides. Well, sorry, let me plug in 0 for y first. But when you're solving and it's in vertex form, you want to get the squared part by itself. So we're going to subtract 9 from both sides. Divide by negative 3. And we got it by itself. I'm going to switch sides. Take the square root of both sides. Don't forget the plus or minus. And we get x plus 2 is this positive and negative square root of 3. And so x is negative 2 plus or minus the square root of 3. So my roots are x is negative 2 plus the square root of 3, and x equals negative 2 minus the square root of 3. My x-intercepts are going to be negative 2 plus the square root of 3 comma 0, it's a point, and negative 2 minus the square root of 3 comma 0. And the square root of 3 is between the square root of 4 and the square root of 1. So the square root of 3 is between 1 and 2. We're going to use all that now and put all this together to make our graph. When I graph, I'm looking at, well, what's my center, right? Center's at negative 2, so I'm going to push the graph to the right a little bit so that my center could be at negative 2 here. Y-intercept's at negative 3. So there's a matching point on the left side of the graph at negative 4, negative 3. X-intercepts are at negative 2 plus root 3. Well, let me do the vertex first. So negative 2, 9. And then my x-intercept's negative 2 plus root 3. So plus root 3 is a little bit more than 1, a little bit less than 2. And starting at negative 2, go to the left a little bit more than 1, so about right there. And so we got our parabola shape here. I'll label those points. So we got negative 2 minus root 3 and negative 2 plus root 3. Got my graph. Domains, all real numbers. Range, we have a maximum value at the vertex at a height of 9. So it's all y values less than or equal to 9. This is increasing on the left side of the middle, so when x is less than negative 2, and decreasing on the right half. And the 5 points I used are negative 4, negative 3, negative 2 minus root 3, 0, negative 2, 9, negative 2 plus root 3, 0, and 0, negative 3. Alright, I hope things are going well with you, and I hope this is making sense. I know it's getting a little more difficult. Take your time on this. Maybe go back over some stuff. Try it on your own. Things are going to continue to build off of what we're doing, so it's important that you understand this. If you need to, go ahead and shoot me an email with any questions you have.